Uh, Hello everyone, dear viewers. Today we'll be doing the Y-Channel Microfluidic device on SolidWorks character. Before going to that, just open a new part. So in that, let's first open an assembly, and in the assembly we'll create the microfluidic device. Okay, so give some time to just get open the assembly. So once it opens, it just pops up the new window to import the files, but just close it and go back to assembly, and instead of inserting components directly, just click below and create a new part, and we can rename this we can rename this a rename option over here and rename it as a base. So we write down as Y channel base. Okay, and then just right click, or you can see this part, edit part option. Click on the edit part and followed by go to sketch and click on the sketch and select the plane that you want to do. For example, in this we select the front plane. You can do the same thing from here. You can select the front plane, and then for now let's create a rectangle of 20 mm cross 40 mm. So always make sure that your sketch is fully defined, and then go to features, extrude boss, and this key base is around somewhere 4 mm, and it completely depends on your 3D printing requirements. And once it is done, just select this face and create sketch on this. So for today we'll be doing the Y channel. So in the Y channel you have go to midpoint line. You can do anything you want. Now you just drag it so you can see this, right? And then same way create a line and then give the smart dimension between these two as 45 degrees, and followed by give the dimension of this around 10 mm, and just see where it is moving, which direction. So if you see that it is, just click and hold this uh, point, you can see where it is moving, and that is the reason it is underdefined. So now just press Ctrl Z, and we are sure that it is moving since there is no constraint between this point and this. So assuming this to be 15 mm, or you can keep it as 10 mm. Okay, let's keep it somewhere around 12. Okay, and then same thing you can do, or you go to mirror entities, select the entities that you want to mirror, and create a copy about this time, and followed by you can trim this portion. Okay, see, it's again mismatched. So to avoid that, you just try to pull. You see that it is moving because there is no constraint in the center axis. Just create a center line, so it is automatically it is constrained, and then followed by, you see this thing, so this has no constraint, and similarly we'll constrain this point with this line somewhere around 5 mm. So now if you see, again the sketch is fully defined. Followed by we'll create the inlets, and outlet, and the regular dimensions that we use is around 1.75 mm. So I use the same here. Done. And it's very simple now. You can just create an offset, and here the important note, since we had to create a closed microfluidic channel, so you can just select bidirectional and construction geometry for the baseline, and the parameters, since we have selected bidirectional, for example if you wanted to give 1 mm channel, so just press 0.5 mm. Since it is bidirectional, it will take both sides now, so that each side it will constitute 0.5 mm and completes 1 mm channel. In case if you wanted to reduce it to 0.5, just press 0.25, so overall it becomes 0.5 mm microfluidic channel. So press OK, and if you see these points, you just go to trim and remove these extra portions. Yeah, and same here. And same with this. Yeah. So now if you see, this shows the closed microfluidic chip. Okay. So this is how it looks like. Right. And now go to features back and cut extrude. So if you see, it is facing downwards and will give a depth of 1 mm. Okay. This is how the Y channel has been made. And in short, if you wanted to edit something, go to sketch. Sorry, not the sketch. Cut extrude sketch. Create sketch. And here we can give a little fillet. Somewhere we can give around close to 1 mm fillet or 0.5 mm fillet. Yeah. The same thing you can give it at this edge. Just avoid the stress corners. Okay, let's come back of the sketch. So now we will see a microfluidic channel with 1 mm depth and 0.5 mm width. In the same way, just if you wanted to close this microfluidic channel, then just create a one more layer, or instead of this, exit the component completely and go back to assembly and insert a new part, and we can rename this part as Y-Channel top. Okay, just press enter, and then the same thing you have to do, click on it and go to edit part. And once you do this, select the face that you wanted to perform the next step. Select this face and go to sketch, and now again select a rectangle. So now I have not selected the center rectangle, instead the end point rectangle, and then once it is like join corner to corner, and then create the circles. The dimensions. Make sure in all the cases it should be fully defined. So now this is again fully defined. Okay, let's extrude it again. And in this case, I just extrude 0.5 mm just to close the entire microfluidic channels. So if you see, this becomes a complete closed microfluidic channel. However, just select the same case, edit it back again, and over this surface, let's give a circle, one more circle, and dimension of 1.75 mm. So this we are creating to extrude the inlets and outlets, and select the center rectangle option, this portion. So this thing can help us with the tubing and gripping the tubings. So this can be 3 mm, and same way this can be 3 mm. And same dimensions we can give it to this. And same with this. So once it is done, go back to features, extrude. This again you can extrude to 3 mm. So finally you can see a complete microfluidic device, and if we just make a transparency of this, so you can see internally it has a microfluidic channel. Okay. So if you have any doubts, please pin me in the comment section. Thank you for watching.